Hello everyone, I'm Harshini and Raj studying in Sri Venkateswara College of Engineering, Bangalore. I'm currently in 7th SEM in the Department of Information Science and Engineering. In today's video, we'll be seeing about Hadoop system. The topics which I'll be covering in today's video is what is Hadoop, Hadoop architecture diagram, Hadoop architecture explanation, how data is stored, managed and replicated in Hadoop. First, what is Hadoop? Hadoop is an open source distributed computing framework designed for processing and storing vast amount of data. Its core components, Hadoop Distributed File System that is HDFS and MapReduce, enable the parallel processing of large data set across the cluster of computers. Hadoop's strength lies in its scalability, allowing seamless expansion to handle growing data volumes. The ecosystem includes projects like Hive, Pick, Shark, and HBase, offering a comprehensive suite for diverse data processing needs. Hadoop has become a cornerstone in big data analytics, empowering organizations to efficiently manage and derive insights from massive data sets, revolutionizing the way data is processed and analyzed. Here we are the picture of HDFS architecture is displayed. The HDFS architecture typically consists of the name node, the data node, and the metadata. Explanation. Hadoop architecture pivotal in big data processing is an open source framework featuring the Hadoop distributed file system that is HDFS and MapReduce. It empowers organizations to store, process, and analyze vast data set across the distributed clusters. Key components like the name node and data collaborate to ensure efficient, fault tolerant data management and analytics. The Hadoop architecture consists of the following. The first is the name node. The role of the name node is centralized metadata repository. The function is manages the file system namespace and controls access to files by client. Characteristic single point of failure addressed by secondary name node and crucial for overall system functionality. Next, we have the data node. The role of data node is that it is responsible for storing actual data blocks. The function is that it executes read and write operation as instructed by the clients or the name node. Characteristics. Multiple data nodes collectively store the distributed data blocks, ensuring fault tolerance to replication. Next, we have the client. The role of the client is to initiate the request for file operation, and the function of the client is to communicate with the name node for metadata and interacts directly with data nodes for actual data retrieval or storage. The characteristics of client is to request for read or write operation or initiated by the client, making it an essential component in the Hadoop ecosystem. Next, we have the metadata. The metadata role is information about the structure, organization, and attributes of the data stored in the Hadoop cluster. The function is to manage and store by the name. It is managed and stored by the name node. Metadata includes details like file name, permission, and the physical location of the data block. Characteristics of metadata. It is efficient management of metadata is crucial for maintaining the integrity and accessibility of the distributed file system. Next, we have the block operations. Hadoop file system, distributed file system HDFS, breaks large file into blocks, typically 128 MB or 256 MB, distributing them across data nodes for parallel processing, enhancing the performance. Metadata operation. The name node manages metadata crucial for tracking file structures and block location, ensuring sufficient file system navigation and access. Next, we have the write operation. Client interact with the name node to initiate writes, allocating data nodes for parallel storage, optimizing data ingestions. Replication. HDFS ensures fault tolerance through block replication, creating multiple copies across data nodes, enhancing data reliability and availability in case of failures. The next topic which we'll be discussing is how is data stored, managed, and replicated in HDFS, that is Hadoop distributed file system. Data first we have the data storage. Hadoop distributed file system stores data by breaking large files into fixed size blocks, commonly 128 MB or 256 MB. This division enables efficient storage, retrieval, and parallel processing. The blocks are distributed across multiple data nodes in a Hadoop cluster, promoting parallelism and scalability. This design facilitates the management of extensive data sets by distributing the workload across the cluster, making HDFS a suitable solution for handling large scale data. Data management in HDFS. HDFS relies on the name node as a central metadata repository, managing crucial information about the file system, structure, and block location. Client interaction with the name node to interview metadata ensures organized file system navigation. This centralized approach to data management is essential for maintaining the integrity and accessibility of the distributed file system. It streamlines data operation, contributing to the efficiency of Hadoop in handling extensive data set and supporting a robust and scalable architecture. Lastly, we have the data replication in HDFS. HDFS ensures the fault tolerance through block replication, creating multiple copies of each data block. The default replication factor is typically set to 3, meaning each block exists on 3 different data nodes. This redundancy serves as a protective measure against hardware failures, ensuring data reliability and availability. Replication plays a crucial role in the resilience of the Hadoop ecosystem, allowing the system to function seamlessly even in the face of node failure. It enhances the overall robustness of of HDFC, contributing to its replication. And that's all in today's video. Thank you.